Okay, let's have the solution to example 14. The 20-meter simply supported girder of a bridge must carry 3 axle loads of a truck which pass along the center of the girder, with the front axle carrying 20 kilonewton load and the rear axles carrying 80 kilonewton each. The front axle and the middle axle are 4.3 meters apart, while the rear axles are 9.15 meters apart. So calculate the maximum bending moment in the girder due to the live moving axle loads plus the impact. The impact factor is given by 15 over L plus 38 and should be less than equal to 0.3. Also compute the maximum shear plus the impact. So first, let's position the loads to cause maximum moment, and we observe the position of the loadings. So there is a possibility that the maximum moment occurs under the 80 kilonewton load. We have two heavier loads, but they are equal. But because 20 kilonewton load is close to the middle load, so we suspect that the maximum moment occurs under the 20 kilonewton load, because if we arrange the loads, that the 80 kilonewton load, which is load 2, is closer to the center of it. So that's 4.3, the other one is 9.15. This is the resultant of the loads, and all the loads will be on the span because the span is 20 meters. None will be off span. So this is equal to 180 kilonewtons. We will call the distance of R from load 2 as E, then apply Varignon's theorem to solve for E. That is 180 times E equals 80 times 9.15, then minus 20 times 4.3. So 180 times E equals 80 times 9.15 minus 20 times 4.3. Solving for E is 3.589 meter. So we imagine that the center of the beam is the passing through the midpoint of E. So it's here. So that's the center of the beam. So this time, let's solve for reaction at the right side. So this distance is half of 20 minus E over 2. So 10 minus 0.5 of E, which is 3.589, so 8.2055 meters, which is the same distance of load 2 from the right. So that's also 8.2055. Summation moment about 0.1, so that it's convenient to solve for maximum moment up to as R2 times 8.2055 minus 20 times 4.3. You can also compute R1 if you want. And moment at 2 is R1 times 10 plus 0.5 of E, then minus 80 times 9.15. That's also the same. But let's just solve for R2. So R2 times 20 equals R 180 times 8.2055. Solving for R2 is 73.85 kilonewtons. So maximum moment is R2 times 8.2055 minus 20 times 4.3. So maximum moment due to live loads is 519.98 kilonewton meter. Next, let's solve for the impact factor. By the way, if the maximum moment occurs at 3, you are doubtful, then we can do that. I will show that the maximum moment occurs under load 2, not under load 3. But for the benefit of the doubt, so let's solve for maximum moment when the maximum moment occurs under the 80 kilonewton load, which is marked load 3. So this is R. So this is E1. So E1 should be 9.15 minus E. All this still R1, but this R1 is not equal to that R1. This R2 is not equal to R2 because of the different load positioning of the loads is different. So 180 times E equals, so this is our reference. So 180 times E equals 80 times 9.15 plus 20 times quantity 9.15 plus 4.3. So E sub 1 is 5.561 meter. The other way is it is 9.15 minus E, which is 3.589. So therefore, this distance is 10 or L over 2 minus E1 over 2. So 10 minus 0.5 of E1, so 7.2195. This is the same distance as that of R So that summation moment about 0.2 equals 0. So you have R1 times 20 equals 180 times 180 times 7.2195. So R sub 1 is equal to 64.98. So the maximum moment here is simply R1 times 7.2195. And comparing to the maximum moment which occurs at R2, this is less. It's only 469.12. So that's why the explanation earlier that since we have equal heavier load, and because the 20 kilonewton load is closer to this heavier load, so we conclude that maximum moment occurs at 2. So let's solve for the impact factor, which is equal to 15 over L 20 plus 38, so 0.2586, which is less than zero point 0.3. So this is the impact factor. The maximum moment, therefore, is equal to 519.98 times the quantity 1 plus 0.2586. So the impact contribution is 519.98 times 0.2586, while 519.98 times 1, that's the moment due to the live loads alone without the impact. So with the impact, the maximum moment is equal to 654.4 kilonewton meter. Then the maximum shear is the reaction, and because R is closer to 3 than that one, and we position load 3 over R1. So Vmax equals V summation moment about 2 equals 0. So Vmax, which is R1, times 20 equals, imagine that load 3 is here. So the distance of 180 from, so this is 80 over R1. So its distance from the right is also 20. Then plus 80, this 80 here, its distance from the right is 20 minus 9.15 because load 3 is here. So load 2 would be here. The distance of load 2 from R1 is 9.15. So its distance from R2 is 20 minus 9.15, so 10.85. Then plus 20 times quantity 20 minus 9.15 or 10.85 minus 4.3. So 20 times 6.55. So 6.55 is the distance of load 1 from R2, and that is 10.85 minus 4.3. So you'll get 6.55. So the maximum shear without impact is 129.95. So with impact, so you multiply this by multiplying 1.2586. So the maximum shear plus the impact is equal to 163.56 kilonewtons. So that's the solution to example 14.